Hi, everyone, and thank you for joining us today for a collaborative future human expertise in AI and predictive maintenance. My name is Auburn Meadows, and I'm the Community and Events Manager here at AssetWatch, and I'll be your moderator and host today. Before we get started, wanted to share a few housekeeping notes with you. First, this webinar will be recorded and shared with you post-broadcast. Second, we will have a live Q&A at the end of the presentation, so please drop any of your questions in the comments box. If we run out of time to answer your question live, an expert will reach out to you directly after the broadcast. Let's go ahead and get started. If you work in industrial maintenance, chances are you're dealing with a flood of data. Vibration trends, oil analysis reports, temperature readings, the list goes on. These data points are essential for keeping equipment healthy and operations running smoothly. But without the right tools and expertise to make sense of it all, critical insights often get lost in the noise. That's where a smarter and more collaborative approach to predictive maintenance comes in. By combining the speed and scale of AI with the experience and judgment of human experts, maintenance teams can make faster and more accurate decisions, prioritizing what matters, preventing failures, and extending the life of your assets. Before we dive in, I'd like to introduce you to today's speakers, two people who bring a powerful mix of technical expertise and real-world insight to the conversation. First up, we have David Murphy, CME Program Manager here at AssetWatch. David has a Cat 3 vibration certification, level 1 thermography, and he's certified as an MLA 1. David has over 7 years of hands-on experience in the reliability space and has a background in field fan balancing, laser alignment, ultrasound, and motion amplification training. He's on the front lines every day helping customers interpret complex data and take the right action at the right time. Joining David is Garrett Coleman, Customer Success Team Lead at AssetWatch. Garrett plays a key role in helping customers bridge the gap between human insights and AI-driven tools. He's a champion for clear and empathetic communication and is passionate about making condition monitoring more approachable and impactful. Garrett is especially skilled at aligning cross-functional teams to deliver people-first solutions that drive real value. Together, they'll share practical tips, real-world examples, and a fresh perspective on how to make predictive maintenance work better for your team, for your equipment, and for your bottom line. With that, I'd love to hand it over to David and Garrett.
Hey, everybody. Like Albert said, I'm David Murphy. I'm going to go over the agenda a little bit. We're going to do some poll questions and then go through some case studies for my section of this. So first thing we're going to talk about today is the basic challenges of reliability teams, what AI is and how it differs from machine learning, some basic tips, problems when using AI and machine learning and condition monitoring technologies. Like I said, some case studies, and then how to use AI to optimize your maintenance program. So maintenance teams are being asked to do more with less, shrinking headcounts, tighter budgets, and a loss of seasoned experts that are raising the stakes. Unplanned downtime is still a major budget killer. Costly repairs, replacements often stem from lack of real-time visibility into asset health. Outdated maintenance methods fall short. Manual, time-based inspections can miss early warning signs of asset failure. The skills gap is widening. So as veteran technicians retire, teams are left without the deep tribal knowledge they once relied on. Data without context is just noise. So without AI-powered insights and expert guidance, teams struggle to turn raw data into smart maintenance decisions. All right, I'm gonna ask our first poll question here. So, do you know the difference between machine learning and AI? Yes, I've seen the Matrix. Maybe I use ChatGPT for work emails. No, I live behind a rock, a wall. Sorry. And how did I get to this winner bar? Yes, I use AI and machine learning in my day-to-day operations. And no, but I'm excited to learn more. I'll give you guys a couple minutes to answer here, or maybe a few seconds. All right. So it looks like 53% of us don't use it currently, but we're kind of excited to learn more about it and use it more. 24% of you have seen The Matrix. That's good. One of my favorite movies. A lot of you use ChatGPT for emails. I also do the same. All right. Let's jump into the next slide here. Okay, so I'm going to break this down simply. So AI broadly refers to machines or software that can perform tasks that normally require human intelligence. Okay, that's AI, right? The different goals of AI, and there's some examples of Siri, Alexa, chatbots, self-driving cars, and facial recognition. The difference between AI and machine learning is machine learning is a subset of AI that gives machines the ability to learn from data without being expertly programmed. So let me break this down simply. You feed a ton of data, past and present, to an algorithm, right? And it starts to recognize patterns. Then it uses those patterns to make smart predictions about what might be happening next. That's AI in action. Machines mimicking human intelligence to anticipate problems before they occur. More specifically, machine learning, a subset of AI, learns from the data and keeps improving. The more data it sees, the better it gets, spotting failures, patterns, and problems to give you a heads up. So let's think of it like this, right? So AI is a coach setting the strategy, right? Machine learning is the player on the field, constantly learning and getting sharper with every play and every time they practice the same thing over and over again with a little bit of coaching. So you may be asking yourself, well, why does this analogy you just made matter for maintenance, right? Because AI can process massive amounts of data around the clock. Machine learning models learn from equipment history and improve future predictions. Together, they can catch problems earlier and more accurately. So we're going to talk about kind of the reactive past and how a proactive future with AI can be more beneficial. So maintenance, here's how it kind of looked, and here's how it's evolving with AI, right? So before AI, right, analysts were digging through manual data sets, ton of data, decisions were slower and more reactive, and costs were pretty high. With a reactive model, you're not detecting when things start to fail at an early stage. You're simply waiting for the equipment to fail. When the equipment does fail, it's all hands on deck to either repair or replace. This pulls maintenance staff away from assigned tasks and puts you behind schedule. And what if the replacement isn't in stock? Or what if the repair parts have a very long lead time? What do you do then? I'm sure all of you have dealt with this at some point in your career. So with AI, right, the data can be analyzed in real time and way faster. A lot more data can be analyzed. The AI models are constantly scanning for changes and sending alerts when something's off, often before a human would even notice. This means quicker insights, less guesswork, and smarter use of your team's time. The bottom line is AI doesn't just help you work faster, it helps you work smarter with less time reviewing data and more time solving real problems. So we're going to talk about a form of AI called optical character recognition, right? So this is something that we use here at AssetWatch to basically extract information from a picture and put it into something, a format, right? So if you upload a picture of a motor nameplate, so the first thing that this does, it detects all the text on the image using a machine learning model, as you can see here. Then it draws a box around each text region, reads that text using a different machine learning model, and last it returns the text as well as box coordinate locations in a specific developer-friendly format that can be used in a multitude of ways. So how we use it here at AssetWatch is we basically extract this information from a motor. And we use that information to populate different things in our software, bearing information, horsepower information about the motor, right? So this is all an example of a machine learning tool that can take a lot of data and process it in seconds. So imagine how long it would take for you to look at, like, let's just say 1,000 pictures and populate that data from a picture into a developer-friendly format. This is one of the many ways AI can be used to help quickly work through mountains of data in seconds. So this is another thing that I just ran this picture through ChatGPT, and I wanted to see what this is another recognition system, right? I wanted to see what ChatGPT thought versus what I thought, right? So I put this picture through ChatGPT of an industrial. This is what it said, right? It spit out this whole thing right here. It said it's an industrial blower exhaust fan. There's severe corrosion. The casing is badly rusted, especially around the inspection ports and the structural frame. Some holes appear to be eaten fully through. The motor condition, the electric motor seems to show signs of advanced rusting, likely overheating or age-related damage. The fan cover is heavily corroded. Degraded electrical components and the green electrical cables appear to be intact but exposed to weather and likely past due inspection. Right? That's what I just dropped it in Chat GPT and this is what it spit out. So I'm going to tell you what, when I see a picture of this, what I think, right? This is an overhung fan with an electric motor coupled to an inboard and outboard fan bearings, and it's under guarding. I see that there's structural issues. The fan structure as a whole is in question. So if you look at this, you can see the corrosion, but if you look at the bottom, like right in this center area of the fan, you can see one of the springs is actually 90 degrees rotated incorrectly, right? So it's not working as intended. So this is just a little bit about how a human thinks that's actually in this space doing this over when I just drop a picture into Chat GPT. We both see kind of the same thing, but it's just a little bit different. So AI is changing how reliability teams stay ahead of machine failures. AI uncovers trends, flags anomaly, and predicts failures before they can impact operations. This gives your team the space to shift from reactive firefighting to proactive planning. You're not chasing issues anymore, you're preventing them. Think of AI as a digital expansion, digital extension, sorry, of a reliability strategy, right? It's always monitoring, it's always learning, and always ready to alert you before something goes wrong. So what's the result of all this that I just said, right? You have more uptime, fewer surprises, and sharper focus on the work that truly drives performance. So let, let's just talk about how AI is used, right? Now, there is some caveats to this, right? So you have to capture the right data. We're going to specifically talk about vibration data here, but we as people still need to strategically place vibration sensors that can measure things like frequency and amplitude. Those are like your early warning signs, right? Spotting signs of misalignment, bearing wear, looseness, and imbalance, right? But so we have to capture that data and feed it to our AI algorithms, right? And then the AI machine learning, those models, they analyze the data and compare it to historical baseline trends, right? When something doesn't match up, it flags it and it does it relatively instantly, right? So what else can it do? It can make sense of the data, right? So it surfaces anomalies and your experts step in to interpret what's going on. It's not about replacing people. It's about giving your team smarter tools to work more efficiently, right? So what's the result of all of this, right? Quicker detection, fewer surprises, and more for your team to focus on strategy instead of spreadsheets. We're going to talk about some different um, forms that and kind of how we use it here, right, at AssetWatch, which may give you ideas of how you use it at your facility, right? Let's talk about anomaly detection, right? So AI finds deviation from normal behavior early, right? This proactive approach not only prevents failures, but also reduces unexpected downtime, ensuring smoother operations. It can also do fault detection. AI can recognize known issues like misalignment, looseness, imbalance, etc. So this precision means that maintenance teams can address the right problem the first time, enhancing efficiency and reducing waste. You can also prioritize your assets. So asset prioritization, which means like which piece of machine or piece of equipment needs attention first based on criticality or current condition. This method ensures that critical assets receive timely attention, preventing costly breakdowns and optimizing maintenance resources. So I'm going to give you an example, right? So if I work at AssetWatch. I have a lot of data points that I look at, right? Without a way to prioritize what I'm looking at, I'm going to be just searching through mounds and mounds and mounds of data to get a simple bearing defect, right? Just a simple thing that I could easily find if something bubbled up based on different trends, bubbled up something for me to look at first, right? The last one is an asset summary. So AI can give you a summary of your assets or your facility health. It can also summarize different technologies or what work has been done during a period of time. So if you go on vacation or you haven't looked at your condition monitoring technologies in a while, you can get an AI generated summary of what's happening since you last looked. You can also, if you want to get more advanced with it, you can also base a machine learning model on the comments that the AI algorithm spit out, right? So if it's a good, like this is a good what it spit out to me, rank it high, and if it's bad, rank it lower. And based on the algorithm for the comment ranking set in place, it will get better, showing you more of what you want to see over time. So we have an example of this in AssetWatch, where we have a feature that if you've been out for 7 days or you've been out for 30 days, or you just want to catch up before a meeting, the system will go through all the different data points, all the maintenance recommendations, and all the comments, and it'll give you an example of everything that's happened over the past however many days you choose. Then you can use that and you can push the up arrow or down arrow, and it will get better over time. Um, so speaking of these, this is going to be important for later when we go over the case studies. Just wanted to get a little bit more in depth into anomaly detection and fault detection, just so we know the difference, right? Anomaly detection is something that's happening rapidly, or something changes. There was a process issue, somebody closed a valve, somebody's throttling a valve, something happened to cause an anomaly that's happening fast, rapidly. Fault detection is actually predicting the fault that's taking place via imbalance, looseness, anything like that. The actual system is predicting the fault. So in this section, we're going to look at how AI and machine learning turn raw data into some actionable insights. So comprehensive data analysis. So once again, I've talked about this already. AI can process huge volumes of sensor data in real time, much more than a human can. It picks up on subtle changes that might indicate future failures. So why does this matter? So I'm just going to go into a brief story of how it could have helped me in the past, right? So I'm out in the field and I'm collecting data at a plant. And I go there once a month. There's a pump, then there's a motor, and I'm looking at this motor. There's nothing that I'm seeing in the spectrum. Okay. Then the next time I go out there, the motor is off. The whole equipment's off, so I can't go back and check it the next time I go out there. And a couple months go by, comes back on, and the machine fails. There was a bearing defect on the motor, which we came to find out that because I hit it the first time and it was very early signs, I was only seeing it in the very high end of the spectrum, right? So I didn't think it was time. But when you leave a machine and there's other machines running around it, those can degrade bearings over time, especially if you're not going up there and hand spinning the shaft. So if this would have been the case and we would have actually had a condition monitoring technology that was reading all the time on this piece of equipment, we would have been able to catch that, because we would have had all those different readings in times, would have been prioritized, and we may have been pointed in the right direction by AI, right? Because it detects very small deviations in the very early stages that might be missed with manual analysis. Spots trends over a long period of time. It improves predictive accuracy, saves time and effort by automating data review. It's also looking at the data 24/7, 365. Pattern identification. So machine learning takes analysis just a bit further. It learns from past data to predict future failures. So if we have a machine learning model and we feed it information, telling it what's correct and incorrect, making adjustments to the model, we make it better and more efficient over time. So let's say I have 5 pumps in a row, all with elevated vibration at 1 times turning speed. Right. If anyone is familiar with vibration analysis, you know that this can indicate quite a few different defects, right? That's, if you're not looking for bearings, you're determining what the 1 times turning speed is, right? But if you get down to the root cause of that issue and you adjust the algorithm accordingly for those assets, it'll definitely make the machine learning model better over time. So what does this mean for you? Fewer false alarms. AI gets better at distinguishing real issues from noise, identifying individual defects, and more accurate predictions. AI learns what normal looks like and flags true outliers over time. Predictive maintenance is way better than reactive maintenance. I mean, we all know that. So instead of waiting for breakdowns, AI helps your team schedule maintenance only when needed, saving time, labor, and costs. So let's first talk about what a reactive approach is. I know everyone on this call probably knows it, but reactive approach is when something breaks down, you react to it. You have a spare on the shelf, you go get it, you put it back in, but this is all after the failure occurs, right? And then we'll talk about let's shutdown maintenance. So that's the next one up on the list, right? So a shutdown maintenance approach is basically you plan to shut down, you shut down and you replace equipment that could be problematic but it may still not be problematic, right? It's like a planned shutdown, we just replace things. That can also lead to problems with the bathtub effect, um, and infant mortality in equipment, right? So when you start up equipment, there's a time where it can fail unpredictably. So then we'll talk about more of a preventative approach. That's the next step, right? So preventative maintenance, that's regular servicing your equipment to avoid failures, PMs, condition monitoring technologies, using all those things to kind of have a preventative approach. um, some condition monitoring technologies, right? And then predictive is where I think we all want to be, right? We want to have the predictive approach. We want to use our condition monitoring technologies, vibration analysis, ultrasound, thermography, motion amplification with our PMs in place to keep our equipment running. And then if we have AI getting us faster at these condition monitoring technologies, helping us view what needs to be viewed and not just searching endlessly for hours for deviations in, let's just say, the spectrum, right? If we can actually have it point us in the right direction and even give us some insights on faults, it makes us all better. We're going to get into some real world examples now. The first case study, I'm going to say, so this is one, I'm going to show you how I picked up one and how AI was incorrect on its prediction. Then I'm going to show you one that AI picked up that I didn't catch. And then I'm going to show you how it can be used beneficially with both, right? So this is the first example, right? So we have an exhaust fan. I will get into the fault and how I detected it, but the fault that I detected was imbalance, and the causes identified was buildup of debris on the fan causing imbalance. You can see that there was a uptick in vibration. This is a trend right here. You can see there was an uptick in the trend in vibration. Looks like it was relatively directional, but we'll take a look here. So what I was first seeing when I looked at it, I see elevated amplitude at the fan turning speed, mostly in the axial direction. But if you look closely at this 1 times turning speed right here of the fan, you can see that it's higher in 2 directions over one. This is indicating imbalance, right? Now, when the AI thought this was structural looseness, it saw elevated amplitude at fan turning speed indicated structural looseness. These are two entirely different defects that have entirely different resolutions to them. So what I recommended was inspect the fan, clean the blades of any debris buildup, and balance the fan. The fan was cleaned and balanced, decrease in the fan turning speed amplitude. You can see from this trend right here, the fan was cleaned and balanced. We reset the calculation date, and then the amplitude was much less. Now, this is also what happened. So before it was like zero 0.4 inches per second, and it dropped down to 0.13 inches per second. So we still have some fan turning speed here, but it decreased the vibration overall. So what does this case study tell us, right? So this is an example of an AI detected fault. It detected it incorrectly. It called out structural looseness. So if I'm the customer and I get just the AI generated fault from a system and it tells me there's structural looseness, I'm going to go tighten some bolts down, or I'm going to go look at different issues, right? Maybe there's some cracks in the base or some broken welds, but that's not really going to fix the problem. The problem was imbalance. So this is how the two come together. Condition monitoring engineers using the power of AI come together to actually fix the problem. We'll go into the next one. Now, this is one that I did not detect, right? This is one that AI picked up this fault, and we'll talk about it. Um, and I didn't detect it until after the fact, right? So this is a temperature trend of a piece of equipment. The temperature started to increase at 5:22 p.m. So this is after, I've been logged off for an hour or so, right? The temperature continued to increase and AI flagged the anomaly at 6:22 p.m. So it's first saying, hey, there's something wrong here at 6:22 p.m. Then the AI generated an email to the customer and myself now about there was an increase in temperature at 7:23 p.m. because it needs, before it can flag to go to someone, unless the anomaly is really crazy, we try to give it time to just confirm that it's correct, right? So the customer called the plant after hours to let them know that the temperature was increasing on this piece of equipment. So this is what the email to the customer looked like. So you can see it says there was an anomaly detected. So there was a rapid change in temperature. This thing will work for me. So there was a rapid change in temperature. Tells you what the equipment was. Tells you that it was on the motor ODE point. And then it tells you we'll get back to you. It tells you to do a look, listen, and feel inspection of the machine, and actually gives you a link to go to the piece of equipment if you want to view that, right? So what ended up happening? So the following morning at 8:28 a.m., upon inspection, they found that the motor cooling fan was broken. This was after me and the customer connected, but we found that the motor cooling fan was broken. So the resolution was they replaced the motor cooling fan. As you can see, the temperature decreased and the train goes back to normal. So this is one thing where in the later hours in the evenings or at different times, things can still be sent to you to get notifications on different things that are happening with your equipment without the intervention of a condition monitoring engineer, depending on how you have the AI and machine learning algorithm set up. Let's talk about one that is both of us, right? So on this particular example, this was a fan, a system fan. So the AI sent me like an increase. It flagged it. It said there was a change in vibration. We call it a rapid change alert here. So it sent me a rapid change alert. I took some additional readings. That's what all these little triangles are, because I was trying to figure out what the problem was, trying to diagnose the fault. And this is kind of a strange one. So this is how the spectrum, the time waveform, the acceleration spectrum look, right? So we have some harmonics of turning speed. We have a raised noise floor. We have a lot of shaft speed impacted in the time waveform. So this looks to me like rotating looseness. Now, here's the problem. Right after that happened, the vibration decreased. It went back down to normal levels. And I was thinking, well, could this just be like a blip? Could this be load related? Could this be product consistency related? Time went on a little bit, and then I got another notification. So less than 24 hours later, I got another increase in amplitude, right? So if we look at the spectrum of this one, so now it was really clear to me what was going on. It was definitely rotating looseness on the fan ODE bearing. I put in a maintenance recommendation to inspect the fan DE bearing by using a dial indicator and performing a lift check. Since it's hard to distinguish between the bearing being loose to the shaft or the housing, I also recommended that the upper half of the bearing cover be removed to inspect the bearing for signs of damage and wear, just the outer race of the bearing, right? And you can see the waveform, the acceleration spectrum, and the velocity spectrum. So the fan was shut off. They inspected both bearings. They found looseness in the ODE fan bearing. The load on the equipment was changed because the vibration amplitudes were. So this is actually what happened, right? So when you start to get excessive load on your equipment and you have an imbalance problem, it can also lead to rotating looseness, because each time that fan wheel spins, it's putting excess load in all directions on your bearing, right? So it's causing imbalance and increasing the vibration. The imbalance causes the bearing clearances to open up over time. And if the load on the equipment changes often, this can happen rapidly. So you can see from this case study, right? So what would have happened if I would not have been notified again that there was another rapid change in the machine? I may not have looked at it right when I needed to. I may have pushed this off and then looked at it later because the amplitudes went back down. So the good thing about that was that the AI notified me that there was another change. We figured out what the problem was. We gave the customer the information and we avoided a catastrophic failure. All right, I'm going to hand this off to Garrett now. Thanks for letting me present this portion.
Thanks, David. Hey, everyone, I'm Garrett. Just want to be clear here that AI is here to enhance, not replace your team. When I first started hearing all the buzz about AI, I'll admit I got a little bit nervous. I mean, we've all seen Terminator, right? Skynet becomes self-aware, robots rise up, and suddenly you're running for your life while Arnold Schwarzenegger chases you through a factory. Then you've got movies like I, Robot, where Will Smith is punching androids for predicting crimes. So AI in movies doesn't exactly give you a warm, fuzzy feeling. But real world AI is a lot less world domination in Hollywood and way more digital assistant who never needs coffee breaks. It's not replacing people, it's helping people be even better. These days, I use AI all the time. At work, it helps me catch up after PTO, helps me rewrite emails so I don't sound like I type them while juggling kids and chaos and keeping track of a million other things. At home, it helps me plan my kids' schedules, spit out chore charts, and even drop new flag football plays when my creative think tank is on empty. Hasn't won us a Super Bowl yet, but let's give it a little time. And let's be real. I'm sure some of you have had a machine go down and thought, if we'd have just caught that one day earlier. AI delivers insights, but you make the decisions because it still takes a human to hear weird noise and say, yeah, that doesn't sound good. So now we have our second poll. So how many of you use a smartwatch? Yes, I have the best of the best, Apple. Yes, I have an alternative brand. It's a little less smart. No, I'm still stuck in the wall that David mentioned. Or no, but does anyone have the time? I'll give you guys just a few seconds to get your responses in. Cool. So it looks like we got several people still stuck in that wall, but we've also got a pretty good portion that is either uses an Apple Watch or uses some other type of smartwatch, whether that's a Samsung or Fitbit. The point being is think of AI and predictive maintenance like giving your equipment an Apple Watch. It's constantly collecting that data of whether it's vibration, temperature, runtime, and then when something starts trending in the wrong direction, it gives you a heads up. Just like your Apple Watch might say, hey, your heart rate's spiking even though you're just sitting on the couch, or maybe you haven't been getting enough sleep lately and it's telling you that your sleep trend has changed. Predictive maintenance and AI might say, hey, this motor's showing signs of failure even though it's still running fine. It's not trying to replace you, it's trying to prevent surprises. Because while machines are great at processing data, they can't make judgment calls, and that's where humans come in. We still need people to interpret complex issues, filter out false alarms, and take real-world conditions into account. And this is where we bring it all back to the people in the room. AI and automation are incredibly powerful tools, but without human insight, they're just data processors. It's the human element that makes us all work. First, we have human analysis. AI might highlight an anomaly, but it's the person on the floor, the technician, the engineer. They know the story behind the numbers. They understand the equipment, the quirks, and the context. They know that just because something looks off in the data doesn't mean that it's actually a real problem, or maybe it does mean it's a real problem and something even bigger is going on. Then you have nuisance alarms. Anyone who's worked with automated alerts knows the pain of alarm fatigue. False positives pile up fast, and before you know it, folks start to tune them out. It becomes the boy who cried wolf. That's where human review is critical. It helps us cut through the noise and only act on what really matters. Next, we have actionable, clear instructions. AI might tell you what's wrong, but it's the human side that figures out what to do about it. Real-world maintenance isn't a checklist you pull from the cloud. It's a conversation. What's the impact? What's the priority? What can we do with the time, tools, and team that we have? And then finally, we keep the facility in mind. Every plan is different, and what works for one location might not make sense somewhere else. Human experts know how to take the insights and tailor them to the unique constraints and goals of their operation. So the action isn't just technically correct, it's practically right for the business. Here you'll see another example of having that human in the loop versus AI. So this picture shows where AI detected a rolling element bearing. You can see that towards the top of the picture there. And we see that it flagged it as a 99% confidence that it was rolling element bearing, which sounds pretty serious. But here's the thing, when you dig into the actual vibration data, especially if you know what you're looking for, you'll notice that it isn't a mechanical issue at all. So if you look closely on the right-hand side, you'll see the 120 hertz sidebands that are around rotor bar passing frequency, which is a classic sign of electrical vibration and not a bearing issue. So what looked like a mechanical defect was actually something completely different. Now imagine had this alert gone straight to management without a human expert reviewing it. The bearing could have been replaced early, which would have been unnecessary and caused extra time, money, and resources to be spent on a repair that didn't need to happen. And that's where that balance comes in. AI is incredibly helpful. It brings speed, scale, and pattern recognition, but without human interpretation, there's a risk of jumping to conclusions based on incomplete context. That's why having a human in the loop isn't just a nice to have, it's an essential and ensures that insights are validated and that the actions that are being taken are the right ones. So here on this slide, we're going to start at the top in the middle. We start with sensor data collection. So we're pulling vibration, temperature, and other operating data straight from the equipment. Nothing new here. This technology has been around for years. But then we bring in AI and machine learning analysis to dig through that data at scale, spotting the subtle patterns and trends that a person might not catch in real time. This leads to anomaly detection, that the system says, hey, something's not quite right here. But just because something looks off doesn't mean it's a critical issue. From there, we get to the predictive insights, and this is where AI suggests what might happen and when. It's like getting a forecast, not just a report. I'm sure some of you have gotten alert from the systems and thought, yeah, that doesn't feel right. And that's where you come into play. The next step is human validation. This is where your judgment matters. Is this really a failure mode, or is it just noise? Is it maybe a change in the vibration because of the load that the machine is handling? And does that line up with what we know about the equipment and how it's running? Based on that, we move into maintenance recommendations, not just a generic fix it, but a specific context aware action plan that makes sense for your facility, your team, and your production schedule. And then the part that's key is we feed that validation back to the AI model. The system learns from every correction, every confirmation, and the more feedback it gets, the smarter and more accurate it becomes. And finally, we have a failure that was prevented. Not guessed, not reacted to, but prevented, because people and technology work together in this continuous loop. It isn't automation just for the sake of it. It's automation with people at the center. So when we talk about AI-driven predictive maintenance, it's important to emphasize that AI doesn't replace the human expertise. I know you guys have heard me say that several times already. It enhances it. The most effective predictive maintenance systems are built on a human-in-the-loop approach where AI handles the heavy data lifting and pattern recognition, while the human expert interprets, validates, and acts on those insights. So what makes an ideal human expert in this setup? So firstly, we have Cat 3 or Cat 4 certification that ensures the experts have a deep understanding of vibration analysis and condition monitoring principles. This level of certification means they're equipped to diagnose complex machineries, issues that AI might flag, but can't fully contextualize on its own. Next, they have field and industry experience, which is crucial. We have some people that may have, been working in mines for 20 years. And that experience is crucial because the AI can detect those faults and anomalies, but the person understands the specific operational context, whether it's food processing or a plastics extrusion line, and they decide the best course of action based on those environmental factors and operational priorities. A basic understanding of AI and machine learning empowers humans to work seamlessly with AI tools. They know how these models process data, what limitations they might have, and when to question an alert or an anomaly. This prevents over-reliance on automation and ensures the system remains both accurate and practical. Then there's hardware knowledge. Proper sensor placement and maintenance are foundational to accurate data collection. Bad data in equals bad data out. Experts know where to position sensors to capture the most meaningful data, ensuring that AI is working with the best possible inputs. Maintenance management and operations experience means they understand the bigger picture, how equipment downtime affects production schedules, resource allocations, and overall plant efficiency. They can prioritize maintenance actions in a way that aligns with business goals, not just machine health. You have data analysis, which allows experts to interpret the trends, validate AI findings, and analyze whether it's a one-off blip or part of a larger issue that needs immediate attention. And then finally, asset-specific knowledge and a solid understanding of how software tools tie it all together. Experts know the nuances of specific machines in operation and can navigate the software interfaces to extract, analyze, and act on data effectively. AI is a tool, but again, people are the ones making the final decisions. So at the end of the day, what are we doing all this for? We want to have optimized maintenance. Using advanced analytics, predictive maintenance can transition from a reactive to a proactive strategy. This shift not only reduces the likelihood of an equipment failure, but also aligns maintenance activities more closely with overall operational goals, ensuring that interventions are both timely and effective. So this slide really highlights the three pillars that make AI-enabled condition monitoring successful, not just in theory, but on the plant floor. So on the left, you have optimizing maintenance schedules. It's great at predicting when the failure might occur and suggesting when to act. But here's the catch. AI doesn't know if your spare part is on back order, if your budget's already locked down for the quarter. And that's where that human oversight is critical. It's not just about what the AI recommends. It's about how and when those recommendations fit into your actual operations. Next is human experts training AI models. This part often gets overlooked. As David mentioned earlier, AI doesn't train itself. It needs input from real-world people with real-world experience. Experts label the data, confirm patterns, and provide the kind of context that no algorithm can guess on its own. That feedback loop is what makes the model smarter over time, more accurate, and more useful, and less prone to false alarms. Next, that last one on the right is building trust in AI. This is a big one because if people don't trust the AI, they won't use it. It's simple as that. Transparency and validation are key. We can't just throw a model into production and say, trust us, it's smart. Technicians need to be part of that process. And when they see their own expertise reflected in the insights and they've had a hand in training and refining that system, that's when the confidence starts to build. Many of you have probably had to explain to someone that just because the system flagged something doesn't mean it's a crisis. And that's the gap that we close when we keep a human in the loop. Together, these three areas, smart scheduling, collaborative model training, and trust, are what elevate a condition monitoring system from being just another tool to something your whole team can rely on. AI-based condition monitoring has many benefits for maintenance teams. Firstly, has a wide industry application. AI-based condition monitoring is designed to handle a diverse range of assets and industries. This universal applicability ensures that regardless of the industry that you're in, that users receive tailored and effective maintenance solutions that enhance longevity and the reliability of their machinery. Prioritization, the ability to prioritize tasks is essential in maintenance management. AI algorithms streamline this process by highlighting which assets need immediate attention and which ones could be put on the back burner. This allows the analyst to focus their efforts where it's most needed rather than sifting through volumes of data indiscriminately. Efficient fault detection. By integrating AI with deeper technical knowledge of experts, equipment faults are pinpointed quickly and accurately. This efficiency is crucial for maintaining operational continuity and reducing downtime across sectors. And on the bottom row, we have anomaly alerts. This AI-driven predictive maintenance alerts you to potential equipment issues in real time to ensure that nothing is ever missed. And then it points you in the right direction. So by properly training the machine learning models, they don't just detect, they direct. By guiding experts toward potential problems, the system helps in uncovering faults that might not be immediately obvious, enhancing their diagnostic capabilities and ensuring more precise interventions. And then the last thing on this slide is dependability and team integration. Trust in your system grows with each successful intervention. So again, going back to my last slide, that building that trust is very important. This cycle of interaction and improvement fosters a team environment where technology and expertise coalesce to form a dependable maintenance strategy that gets better over time. Together, these features not only solve maintenance challenges, but also pave the way for a future where maintenance is more intuitive, insightful, and integrated into daily operations. Actually, I'm going to skip this next slide and then come back to it. I'm going to go to this one for a sec, the 2 slides up for a second. So this is how we build a stronger condition monitoring program. AI-driven monitoring delivers sustainability, which is less waste, fewer failures, and AI optimizes energy use, cuts emission, and reduces waste to align with company sustainability goals. Optimize maintenance, the right work at the right time. It ensures that routine task and optimization of allocation of resources. This not only frees up the time and capital, but also allows businesses to channel those resources into further strategic initiatives, which helps propel growth. It also increases your OEE. Everybody wants to have higher overall equipment efficiency, and AI and human expertise combine to maximize equipment uptime and improve plant efficiency. It also minimizes your downtime. By fixing a failure before it happens, AI-driven predictive maintenance can preemptively identify potential machinery issues. It also empowers your workforce by having more time for high-value tasks. An AI-savvy workforce is a competitive workforce. AI is not going anywhere, and the people that learn to use AI as a tool in their tool belt and not see it as an adversary, are going to help drive innovations and adapt to changing industry demands. It also reduces cost. By having fewer breakdowns, lower maintenance spend, AI reduces unplanned downtime, allowing for lower maintenance expenditure and preventing costly catastrophic failures. And then the last thing is increased safety. By catching problems before they cause accidents, this type of condition monitoring enhances safety by detecting equipment issues early, preventing hazardous failures, and reducing manual inspections in risky areas, which enables proactive maintenance to protect workers. Together, these elements showcase AI not just as a technological upgrade, but a fundamental pillar that supports scalable, efficient, and sustainable industrial practices. So, embracing the future of maintenance with AI. Here's the bottom line. AI condition monitoring isn't just a trend. It's not a nice to have. It's the future of maintenance, and it's already happening on plant floors just like yours. But again, AI doesn't replace people. It helps them do their jobs better. It saves time, reduces costs, and improves reliability. And it only works when people and AI work together. We're not choosing between people and tech. We're getting the best of both. Smarter systems, clearer insights, and fewer surprises, and a whole lot less reactive firefighting. So AI doesn't take the wrench out of your hand. It just tells you when and where to use it. So thanks so much for your time today, guys. Let's open it up for Q&A. We'd love to hear your questions or even your own stories.
Thank you both. Great insights and examples. So let's open it up to our first Q&A question. You both work closely with maintenance teams. How would you describe the current state of data overload in industrial maintenance before adopting smarter condition monitoring?
Garrett, you want to take this one first?
Yeah, I can take this one. So that's a good question, because that's one thing that I hear a lot from when we're onboarding new customers is the data overload that they've gotten from more just automated systems versus having like someone like David or another condition monitoring engineer in the loop. One of my customers last week when I was talking to him was actually the one who gave me the term "the boy who cried wolf." They got so fatigued with getting alerts that weren't really smart alerts. That they at a certain point they ended up just tuning the alerts out and stopped paying attention to the system, because they were either getting alerted with things that weren't actually issues, or when they did get what was a real alert, they had already found and fixed the issue themselves. So by having a smarter system and really using AI and that human together, we reduce those false alarms and that fatigue and actually get them to pay attention to the system. David, I'll toss it over to you if you want to chime in.
No, I think you covered that one. So, yeah.
Awesome. How often are we retraining AI to improve detections?
So you need to give I don't know that there's an exact time limit, right? It depends on what you're searching for, right? So if you're just looking at condition monitoring techniques and fault detection, you need a large sample. So we have a bunch of assets. We tell the model, this is what you need to look for. And then we give it feedback over time, right? Now you can constantly ingest that, but you want to have a few examples of what the correct like analysis was, right? And then feed that back as far as incorrect as well. So you can train it on both ways. So it could be as small as 4 or 5 samples, right? So you have 3 that are correct and 2 that are incorrect. But the larger sample basis will give you better indication on what's actually happening.
That's why that constant feedback with both the customer and with the model are so important, right, David?
Correct.
So next question is, what does it take to implement AI with an existing, more manual predictive maintenance program?
So that can be a tricky one. There's a lot of things that you can do, like you can use a service like ours, AssetWatch, where we already have a lot of these things in place. To use a current system, you'd have to contact your current vendors and see what they have on the horizon for AI. If you have a data science team at your facility, or you can hire a data science team, you can build those models out, and then you would have to have software engineers to implement them into your actual system. So it can be tricky. That's not saying it can't be done. In most systems like ours, AssetWatch, we're constantly improving and getting data science teams involved and making new AI and machine learning algorithms.
Yeah, that's awesome. Definitely definitely some barriers to entry, but there's AI people out there every day getting stronger and faster. So what about for AssetWatch data specifically? Do you feel like it's agnostic, and can someone push the data into other platforms, sort of like a data lake?
So yes, AssetWatch can push data into other platforms via an open API. We also can integrate with a data lake or historian and give you all the data. And then if you want to build your own machine learning algorithms, or if you have a data science team, or you have someone in the background that can do that, they can build algorithms based on our data that we can ingest to your system, and you can base decisions off of that as well.
How often are you seeing that? And for you too, Garrett, since you're working with some customers directly as well.
So the integration portion I see relatively often. The actual making machine learning models and basing that basing decisions off of them without doing a bunch of manual analysis, I'm not seeing as often as we probably should be with the advancements in AI.
Yeah, I would agree with that.
So our next question is talking about how hard it can be to get someone to invest in a service like AssetWatch, especially when their team has a low maturity or knowledge in the system. Do you have any recommendations of steps to get a little closer to that maturity needed to implement something like AssetWatch?
Garrett, I'll let you go first, but I have some thoughts on this question as well.
Yeah, I think that kind of goes back to the building trust portion. So, like people, if they've had experience and they had a bad experience prior to coming over to us, it's hard. It may be hard to get them to buy in at first, because they might think that when we send a maintenance recommendation, it's not actually going to be real. So I think building that trust and putting out good recommendations is how you really change the culture and get people to adopt. Because at a certain level, it's really change management, getting people to adopt a new system. And I think we had a really good example of that a couple weeks ago with having a human and AI. We had a customer in mid-June where we had an anomaly detection email get sent out at like 5 o'clock. So, at that time, people may be getting ready to go home for the day, but the AI picked that up. They were able to shut down the pump. So this pump basically pumps oil throughout their entire facility. It's a thermal oil pump. And it's an extremely critical asset, because if that asset goes down, pretty much the entire facility goes down. They were able to shut that machine down, replace the pump after they confirmed that it was in failure mode. They replaced it with one that was recently rebuilt in Germany. And within a week, that rebuilt pump was already in failure. And so they were able to determine that was indeed in failure. And so that was a way to really get their buy-in. It's like, oh, these alerts actually matter. This saved us from the plant shutting down. And so that really started to build their trust and their buy-in by showing those quick wins early on. So it's not really a simple solution, but I think building that trust and instilling confidence is a big part of that change management and getting that buy-in.
Absolutely.
So if you have a low maturity model at your facility, that means you're more of a reactive or a shutdown basis plant. Some things you can do to change the minds of upper management is talk to them about the failures, right? Get together the technology and build case studies on why these things happen and what technologies could have predicted these failures before they happened, right? So you could do all that, and then you can try out a service. A lot of all AssetWatch, right? So we have a trial that you can do that's very cost effective. So you can try it at your facility, put the data in front of the people to make the decisions, and then go that route. But the first thing that you should do yourself is really get the knowledge of your equipment and what condition monitoring technologies are going to be beneficial for the failures that you're seeing. Do an analysis on that, find information about the technologies, and then provide that information to management and start there.
No, that's great advice from both of you. What about timeline? What's the typical timeline you have on getting the alerts to fix those assets? That I know that that's something that's always going to be changing, but what kind of timelines are you seeing the most often?
Okay. So the timeline, It really depends on the alert, right? So if I'm seeing a slow trend in vibration data, the timeline's going to be longer because the vibration is trending up slowly before the alert can become recognizable enough to do something about it, right? But if it's an anomaly, something that happens quickly, that recommendation can happen right away. Like you saw in my section where the email got sent automatically from the system, that was within 2 hours, right? And that was, if it was an alert that was even higher amplitude vibration, it would have come even faster. But if we're just talking about standard data analysis and looking at it, we try to catch things early. So we're constantly reviewing data and we have AI and machine learning algorithms to bubble up data for us to look at. So as long as those algorithms are working correctly and everything's happening precisely, I can be bubbled up with something in advance when there's changes that are happening. So I can go look at the equipment and predict things over time. Now, there is different defects that you can predict over time, as in we'll just talk about bearings. Bearings degrade in 4 stages, right? The first stage is very hard to see with anything besides very high frequency, different condition monitoring, like different monitoring technologies, vibration analysis, ultrasound, stuff like that. But you have to look up at the very high frequency. And then it goes to a stage 2, right, where you can start seeing it with enveloping and using time waveform analysis. And then at the like end of stage 2, early stage 3, right, is when we should be planning to replace that. And stage 4, it's done, right? So you should have replaced it by the end of stage 3. So that's just an example of a different defect in the timeline. So it depends on the defect and what's happening to answer that question.
No, that's great. And we've got some really great questions coming in, but just another minute left. Any advice to the team in general from either of you?
Garrett, I'll let you go first.
I'd say my best advice is to be engaged. Like if you're going into the predictive maintenance space, the people who see the most wins and return on their investment are the people that are actually engaging with the software. So engaging with the AI alerts or engaging with the condition monitoring engineers and giving them feedback on the recommendations and what they're seeing and kind of working as a team and thinking of us as one of your teammates and not just as a service. So I would say engagement is probably the biggest thing and the best way to see return on your investment.
My advice is do a criticality analysis of your assets at your facility. Find out which condition monitoring technologies can detect those defects, get some information together about those technologies, figure out which one you want to go with, and start somewhere. Just start at a basic, what's going to cover the most amount of assets and give me the most bang for my buck. Start there and then build from that point.
That's awesome. Those are both great pieces of advice. Thank you to everybody who joined us today. If we didn't answer your question, we'll reach out directly. Huge thank you to David and Garrett for sharing their expertise. I hope everyone's walking away with a clearer picture of what condition monitoring can be: organized, proactive, and chaos-free. If you're ready to simplify your maintenance strategy and take the guesswork out of your downtime, we'd love to show you how AssetWatch can help you. Reach out, schedule a demo, or explore more at assetwatch.com. Have a great rest of your day, everybody.
See you guys.